So my guess is that you said that student B did better, right? They're above their average quite a bit compared to the standard deviation, and the person who took the ACT score was about at their average, okay? So you're kind of saying student A was at the average and student B was actually 2 standard deviations above their average, right? Because the standard deviation for the SAT was 250 and they scored a 2000 and the mean was 1,500. So that's 2 standard deviations above the mean. And student A scored about at their mean. So we can say student A, if we talk about what are called z-scores, student A has a z-score of what's a 0, and student B got a z-score of 2. And so student B did better because they had a higher z-score. A z-score tells you how many standard deviations a score is from their mean. So a 0 indicates that the score is at the mean. A positive z-score indicates that they're above the mean, and a negative z-score indicates that they're below the mean. So what z-scores does is it just rescales the values. So if you use this formula that's at the top here and you do this to each individual value in this distribution, and you take the raw scores, which are the x values, subtract their mean, and divide by the standard deviation, you will get a distribution of z-scores, and it just rescales the values. So the z-scores will have a mean of 0. So by subtracting off the mean, now we're recentering the data, and we're making the center of the data at 0 now. And then by dividing by the standard deviation, we're making the z-scores have a standard deviation of 1. It gives a new spread. So now we can put these two different variables on the same scale. So now if we take z-scores, now both the ACT scores and the SAT scores have a mean of 0 and a standard deviation of 1. So now we're going to talk about the z-formula in action. Okay, so on this table here we have the original data, and say here is the shape of the distribution. So say it looks kind of mound shaped. Most of the data is in the middle, okay? And the original data has a mean of -1 and a standard deviation of 2/3, okay? So it looks something like this. And we're going to subtract off the mean. So we can see in this table here that we have the individual values are now a little higher, right? Because we're subtracting off the mean, so we're technically adding 1. And so now you can see that if you add up all these values in the second column here, we'll have an average of 0, okay? And the original was an average of -1. You can kind of see it by just eyeballing the data that will come out to be that. And so the top of the z formula just recenters the data. So it takes it from this -1 here, and now we're just going to move it over to the middle here at 0. So now we have a distribution that has a mean of 0, and the standard deviation is the same so far because we haven't divided by the standard deviation yet. And I'm going to do that on the next slide. So we already subtracted off the mean and recentered the data. And so you can see we have the original that has a mean of -1, and then the x minus the mean has a mean of 0. And z-scores also have a mean of 0. But we're going to divide by their standard deviation. So now you can see that if you look at the table, the z-scores are actually a little bit more spread out because a z-score has a standard deviation of 1, and the original data had a standard deviation of 2/3. So 2/3 is less than 1, and so now the numbers are a little bit more spread out. So by dividing by the standard deviation, what happens is we take our recentered data, the x minus the mean, and we're just going to make it out to here to be from -3 to 3. So we just recenter the data. So now this is on a z-scale. So I showed you how to redraw the distribution, but it's a little easier just to draw the distribution and then redraw the number line. So at the top of the number line, the top numbers are the original scale. So we have a mean of -1, and we go up by 2/3 each time to go to the right and go down 2/3 each time to go to the left. But if you want to translate that to a z-scale, right, the mean's always going to be 0, so that's going to be in the middle. Then we go up by 1 each time to the right, and we go down by 1 each time to the left. So this is just easier to draw if you want to rescale it.